total order broadcast versus sequence of values. One line answer is given any two items. Can you decide which came first and which came second? Can you decide ordering between any two items? If you can, that's a total order broadcast. And I actually miswrote the doubt here. It's not versus. Total
Yeah,
order broadcast
exactly.
itself is sequence of values versus the formal consensus with those four properties. So yeah, so the question is whether you do repeated rounds of consensus or do you just do total order broadcast, which itself is a hard thing, as we have seen previously. Um, and they are saying, yeah, they just do total order broadcast. I'm really not sure if this is answering your doubt, Smith. Do you want to like re-articulate your doubt? Where were you confused?
Yeah, like basically, how is it different? How these two things, the formal consensus and the sequence of values leading to total broadcast.
So if you had to do consensus, you will have to propose something,
Hmm.
and then everybody will have to vote and do some consensus building, and then eventually you terminate and say that yes, we have arrived at a consensus,
Hmm.
and this is the value we agree upon. That's a very roundabout way of like doing something, right? Instead, you just say you just assign sequence numbers, and then in whatever sequence they appear, that automatically builds the consensus. There is no voting required. There is no consensus algorithm required. So the moment you put sequence numbers on something,
Mhm.
you have a sequence, right? There is no confusion. There is nothing to agree with,
Okay. Okay. So
which is
just
the
one
hard
thing.
truth, right?
Yeah, I may have missed
Yeah.
this. Like I forgot this from the previous sections. So
Hmm.
how do you again like with sequence numbers? I always have this doubt. Like how do you have like sequence numbering across nodes? Do you have a coordinator for that or not?
Yeah. The short answer is yes, you need to have a single node that gives out incrementing integers. You need to have sequence, like a database sequence that is running on a single node, or an atomic get and increment operation that's running on a single node. Right? And I encourage you to actually go back and we actually discussed this, and I'll refer you to which part. Uh, did we was it in the master class?
I do recall
Uh,
we discussing this, but not like I don't recall how what we did. So
One second, let me find a slide. I think it was before this. There are basically two options, like the easy and the hard way of doing. I think it was in the yeah, this one discussion 25. Okay. So discussion 25 has a lot to do with what we are discussing today, and this particular slide, this lower right half of the slide. um so either you have a linearizable system or you have a total order system, right? And they are saying either you have something simple that's linearizable and you build the complex total order implementation using it, or you have simple total order and you build the complex linearizability. So what you are saying is the number two here, where you have integer increment, and that's very simple. You have a central node and that does the integer increment for you. um, and you build complex total order systems where you will avoid pushing to a single node, avoid pushing all the data to a single node to arrive at a total order. You just get sequence numbers and then total order will automatically appear without funneling everything through a single node. And if it's simple to funnel everything to a single node, and if it's hard to actually have this this integer increment, um, um,
I have one doubt here. So, will this not again be last right wins situation? Like if you do sequence numbering,
hmm,
will you not be essentially in the case scenario where whatever is the latest, you are just overwriting it?
no, no, because there are two parts to committing this, right? Let's
Okay.
say, let's say, and I'm just going to do this verbally so that you can get through it faster. But let's say the current version of the current sequence number for a value is 100. Okay. Now, both Smith and Vrishali are trying to update it. You will first get the value, and that will have sequence number 100. And then you'll try getting a sequence number for your update. And Smith will get 101, and let's say Vrishali gets 102. Fine. Uh, when Smith will send his write, that will get persisted. So now the new value is 101. New version, whatever might be the value, but the new version is 101 sequence number. When Vrishali writes it, Vrishali will say, here is my sequence number 102, which I have built by using sequence number 100. And that will become the fencing token. So the transaction manager is going to say, oh, you are trying to update something on the basis of sequence number 100, but I have 101. So yours is rejected. And Vishal will actually get a failure. And then she will have to again read, and then she'll see the value with sequence number 101, and then it will go forward. So it is not last right wins. It will avoid the conflicts at the time of write. It will avoid the conflicts. Last, it yeah, it will not. Do you see the difference? This is not last right wins, right?
Yeah, I got it. Got it.
Uh,
Got it.
yeah.
There are because there
Um,
are two phases to it. Yeah. Okay.
and hey, on this integer increment, right? Um, um, look at the complex side of linearizability. What is like what is the complex linearizable where integer increment is not going to suffice? Is claiming discrete values. If you have to claim usernames, can you just claim unique usernames and avoid conflicts by working with a integer increment sequence? Not really. Not really. That's a more complex case. So that one, you have to use sequential logs. You have to funnel everything to a single node, use the sequential logging, and then get the linearizability. You know what? So this really goes down to the details of these algorithms, and this is best understood through actual examples. The example is going to converge to that same sequence number 100, and then both Smith and Vrishali trying to update it. Um, and it's fine. Like Vrishali's sequence number 102 is going to be rejected because sequence number 102 ka value was built with a stale sequence number of 100, but 102 is consumed. And the next version Vrishali proposes will be 103. So there is automatic agreement that 102 needs to be thrown away. 102 is a bad value and we need to discard it because it does not come in the sequence. 102 was built using 100, and by just including those two sequence numbers, ki source kya tha and what's the current, you achieve total order broadcast. So the need of consensus goes away. Need of formal consensus goes away. So Vrushali does not need to propose कि भाई मेरा ये value था, and do everybody agree, and then everybody votes on it, and then after all of that hard work you realize कि नहीं नहीं ये value तो we don't agree, because like whatever Smith committed, that node is going to speak up saying that no, but I have a different value, so sorry, I object. And then Vrushali will realize, and everybody will realize कि oh, this is to be discarded. All of that hard work of formal consensus, of proposing, voting, and then terminating the consensus algorithm does not need to take place.